We often envision the final moments of our world as a grand, theatrical spectacle, filled with the deafening roar of falling cities and the desperate cries of a humanity fighting bravely until the very end. Our popular stories and films have trained us to expect a countdown, a brief window of time where heroes can look into the eyes of their loved ones and find peace, or perhaps orchestrate a miraculous salvation. Yet, the coldest calculations of modern physics paint a far more unsettling picture of the end of everything. According to some of our most advanced scientific models, the ultimate catastrophe would not arrive with a warning siren or a slow, visible decay. Instead, the entire fabric of reality could simply cease to exist in an instant, leaving no time for fear, no space for chaos, and absolutely no opportunity for suffering. In a fraction of a second so small that human thought cannot even begin to measure it, all matter and the very laws of physics that govern our universe could rewrite themselves entirely. This sudden collapse would sweep through the cosmos, erasing every atom, every star, and every memory we have ever created. The transition would occur at the speed of light, meaning that the front of this cosmic destruction would arrive at our doorstep at the exact same moment as any potential signal of its approach. Our brains, which require a slow cascade of electrical signals to register pain or awareness, would never even register that the end had come. To experience this would not be like watching an explosion. It would be like a light switch being flipped to off, with no one left in the room to remember what the light felt like. Imagine standing on a quiet evening, looking up at a sky filled with countless points of ancient light, feeling the gentle breeze of a world that feels incredibly solid and permanent. In the next microsecond, without a single sound or a flash of light, the earth beneath your feet, the air in your lungs, and the stars above are simply gone, replaced by an entirely new and unrecognizable state of existence. There is no lingering darkness left to observe, and no observers left to feel the profound weight of the loss. This terrifying and absolute phenomenon is known in the field of physics as false vacuum decay. It is a concept that challenges our deepest assumptions about the stability of the natural world, suggesting that our universe is built upon a foundation that is fundamentally fragile. The consequences of such an event are not merely destructive. They are absolute, representing a complete reset of the cosmic rules that we take for granted every single day. We live our lives believing that the laws of gravity, electromagnetism, and chemistry are permanent constants, carved into the stone of existence. We build our civilizations, write our histories, and plan our futures under the silent assumption that the canvas of reality will remain empty and ready for us tomorrow. But theoretical physics warns us that this canvas might be stretched over a frame that is poised to snap at any moment. To understand how such an end is possible, we must look past the visible world of stars and planets and peer into the invisible scaffolding of reality itself, where quantum fields dictate the rules of life. The intellectual foundation of this terrifying cosmic scenario was first laid down in the year 1977. It was during this time that a brilliant physicist named Sidney Coleman published a groundbreaking academic paper that formalized the mathematics behind this strange phenomenon. Before his work, the scientific community had only a vague conceptual grasp of how a vacuum could change, but his calculations brought a rigorous, inescapable reality to the theory. To comprehend Coleman's work, we must first look at one of the most fundamental laws governing our entire physical universe. Natural systems, from a simple cup of hot tea cooling down on a wooden table, to the life cycle of a massive star. always tend to evolve over time toward a state of rest. This is the natural path of thermodynamics, where energy spreads out, disorder increases, and objects seek the lowest possible energy state available to them. A heavy boulder sitting high up on a steep mountainside holds a great amount of gravitational potential energy. Because of this, it is inherently unstable, and the slightest disturbance will cause it to roll down the slope, seeking the absolute peace of the valley floor. In our everyday lives, we think of a vacuum as a simple, empty container where all matter has been sucked away, leaving nothing but silent, dark space. But quantum physics reveals that a perfect empty void is nothing more than an ancient illusion. Imagine standing in a room so completely dark and silent that you believe nothing exists within it. Yet, all around you, the air is secretly alive with invisible radio waves, thermal radiation, and the silent hum of distant power lines. At the subatomic level, empty space behaves exactly like this, pulsing with energy that we can never perceive with our five senses. If we were to zoom in on a patch of empty space, magnification beyond anything our modern microscopes can achieve, we would find a restless, bubbling ocean of activity. This seemingly quiet space is packed with invisible, constantly fluctuating quantum fields that stretch across the entire cosmos. Particles of matter and antimatter constantly pop into existence out of this empty space, only to collide and destroy each other a fraction of a millisecond later. This perpetual dance of quantum fluctuations is what keeps the cosmos alive and humming beneath the surface. Every force we experience, from the magnet sticking to a refrigerator to the gravity keeping our feet on the ground, is a ripple on this restless subatomic ocean. Just like the boulder on the mountainside, every single one of these fundamental fields and forces naturally seeks its own lowest possible energy level. They want to settle down into the ultimate state of rest, where they can no longer decay or change. When a quantum field successfully reaches this absolute minimum energy level, it achieves perfect stability. Physicists refer to this ultimate, unalterable state of complete balance as the true vacuum of reality. In a true vacuum, the universe is resting on the absolute floor of physics, safe from any further decay or sudden shifts. It is a state of eternal peace, where the rules of nature are locked into place forever. But this raises a quiet, haunting question that physicists have spent decades trying to answer. How can we be absolutely sure that the vacuum of our own universe has actually reached this safe, final floor? To truly grasp this concept, it helps to step away from complex mathematics and visualize these cosmic energy levels as a physical landscape. We can imagine a landscape of rolling green hills and deep, dark valleys, where a simple wooden ball has been placed near the top of a slope. Gravity immediately takes hold, and the ball naturally begins to roll downward, seeking the path of least resistance. Its ultimate destination is the deepest valley floor in the entire region, the absolute lowest point where it can finally come to a complete rest. In the language of physics, this deepest valley represents the true vacuum, the ultimate and most stable energy state possible. But as the ball rolls down this long and uneven mountain slope, its journey is not entirely smooth. On its way down, the ball might suddenly roll into a small, cup-shaped ledge or a temporary plateau along the hillside. Because of the shape of this small ridge, the ball stops rolling and settles into the center of the depression, resting quietly. From the perspective of the ball, this position feels perfectly stable and secure, and it might remain there for an incredibly long time without moving an inch.
A passing observer looking at the ball might conclude that it has reached its final resting place, completely unaware of the steep drop that lies just beyond the lip of the ledge. Yet, directly beneath this temporary ridge lies a much deeper, wider, and more stable valley floor that represents a far lower energy state. This deceptive state of balance is what physicists refer to as a false vacuum. It is a state of equilibrium that appears permanent, but is in fact entirely temporary and highly vulnerable to any sudden disturbance. The fields that govern our universe, from the forces that hold atoms together to the fields that give matter its mass, operate on this exact same principle. And this is where the theory takes a chilling turn that has kept many researchers awake at night. Current scientific evidence suggests that our entire universe, with all its galaxies, stars, and living, breathing creatures, might currently exist in just such a false vacuum state. This means we are currently living on a fragile cosmic ledge, suspended high above an unfathomable abyss. Every moment of human history, every empire that has ever risen and fallen, and every quiet breath we have ever taken has occurred on this unstable plateau. We look around us and see a world that feels solid, reliable, and ancient, mistaking our long period of quiet for absolute safety. But this peace is only a temporary illusion, a cosmic pause on a steep mountain slope. We are like passengers on a train that has stopped briefly on a high mountain bridge, looking out at the beautiful scenery while completely ignoring the fragile supports beneath the tracks. The universe has remained on this ledge for over 13 billion years, but that does not mean it can stay there forever. The laws of nature are currently resting, but they are not locked into their final, safest positions. In our everyday world, governed by the predictable rules of classical physics, objects behave in highly intuitive ways. If you place a heavy marble at the bottom of a steep hill, it will remain there forever unless someone or something gives it an external push to climb over the crest. A solid wall presents an impassable obstacle to a physical object, and a car cannot simply pass through a concrete barrier to reach the other side. Energy barriers in the macroscopic world are absolute, demanding a toll of kinetic energy from any object that wishes to cross them. But when we shrink our perspective down to the microscopic scale, the comforting laws of classical physics begin to dissolve into a ghostly realm of probabilities. Quantum mechanics, the science of the unimaginably small, operates under a completely different set of rules. At this subatomic scale, particles do not exist in single, definite locations, but rather as hazy clouds of possibility spread out across space. In this strange subatomic world, the rigid boundaries of our everyday experience simply do not exist. Instead of solid objects, we find a realm of constant whispers, where particles act like waves on a lake, spreading their presence across multiple locations at once. A particle does not have a single home. It has a map of potential destinations, and it can inhabit all of them until someone measures its position. Because of this wave-like nature, a subatomic particle has a tiny but very real chance of appearing on the other side of a solid energy barrier without ever climbing over it. It is as if a tennis ball thrown against a brick wall suddenly, silently ghosted directly through the solid bricks and appeared on the other side, completely unharmed and without leaving a single mark. This bizarre and counterintuitive process is known in physics as quantum tunneling. While quantum tunneling may sound like a theoretical curiosity, it is actually a well-documented phenomenon that is essential to our modern technology.
the transistors in your computer chips, and the nuclear reactions that power our sun rely completely on particles tunneling through seemingly impassable barriers every single second. Yet, this same helpful subatomic mechanism holds the potential to bring about the instant destruction of our entire reality. If the quantum fields that dictate the laws of our universe are currently trapped on the ledge of a false vacuum, they are constantly pressing against an energy barrier. This means that the barrier separating our false vacuum from the true vacuum is not a solid stone wall, but a shifting, semi-permeable membrane. The fields of our universe are like a restless crowd pressing against a fragile fence, with every quantum fluctuation representing a gentle push against the wire. In classical physics, these fields would be safe forever, locked securely behind the high walls of that protective ridge. But the laws of quantum mechanics mean that these fields are constantly testing the limits of their prison, searching for a way through the barrier. At any random moment, in any corner of the vast cosmos, a single point in a quantum field could suddenly, spontaneously tunnel through the barrier. Like a ghost slipping through a locked door, this tiny point of space would instantly drop down into the lower, more stable energy state of the true vacuum. This single microscopic event would not remain isolated for long. The sudden transition would trigger an immediate violent chain reaction, releasing an enormous wave of energy that would begin to expand outward in all directions. This expanding bubble of true vacuum would act like a cosmic eraser, rewriting the physical laws of the universe as it travels. It only takes a single lucky particle to find a gap in the fence and slip through to the other side, starting a collapse that nothing can stop. It is a transition that would leave absolutely no trace of the old universe behind, sweeping across stars and galaxies in a fraction of a second. When we look out at the physical world, we see a collection of distinct, tangible objects like rocks, trees, water, and the distant stars. But physics tells us that these objects are actually just temporary ripples on the surface of something much deeper and completely invisible. Our universe is governed by a complex web of fundamental quantum fields that stretch across every single cubic inch of space. We can think of these fields like the water in a massive cosmic aquarium where every particle of matter is just a tiny wave moving through the fluid. Without these invisible fields, the space between the stars would not just be cold, it would be completely devoid of the rules that allow anything to exist. These fields are the silent architects of reality, determining how all matter and energy must behave in every single moment. Among these silent architects, there is one field that plays an exceptionally vital role in the creation of the physical world we know. This is the Higgs field, an invisible grid that permeates the entire cosmos and gives fundamental particles their mass. As particles move through this field, they experience a kind of cosmic drag, slowing them down and giving them the physical weight they need to form structures. Without this constant interaction, particles would fly through the universe at the speed of light, unable to bind together to form atoms, molecules, or planets. At the same exact time, other fundamental forces are working tirelessly in the background of our reality. The strong nuclear force acts like an incredibly powerful atomic glue, binding the nuclei of atoms together against the intense electromagnetic forces that try to push them apart. These forces are not merely passive background elements that we can ignore. They actively dictate the physical laws we experience in our daily lives. Imagine a highly sophisticated computer running a complex simulation of a thriving virtual world. The characters in this simulation go about their days, building homes and exploring their environment, completely unaware of the underlying source code running in the background. They take the rules of their world for granted, assuming that gravity will always pull them downward, and that solid walls will always stop their movement. But if a programmer were to suddenly change a single line of that background code, the physics of their world would instantly rewrite itself. Gravity might suddenly push objects upward, or the boundaries of solid matter might dissolve into thin air, leaving the simulated characters completely helpless. The quantum fields of our universe are the ultimate source code of our reality, running silently beneath the surface of everything we see and touch. If these fields were to suddenly drop into a lower, more stable energy state through quantum tunneling, that source code would be completely rewritten. The fundamental laws of nature that we have spent centuries studying and documenting would simply cease to exist in an instant. An abrupt shift of this nature would destroy the very foundations of modern physics, rendering all of our scientific textbooks completely useless. In this new stable vacuum, the strength of gravity, the behavior of light, and the stability of atoms would be entirely different. It would establish a completely different cosmic order, one where chemistry and biology, as we understand them, would be fundamentally impossible. The old universe would not just be destroyed, it would be replaced by a reality with entirely new rules, where we simply have no place to exist. The sheer scale and implications of a decaying vacuum are so vast that they stretch the very limits of human imagination and comprehension. We are used to disasters that we can see, measure, and prepare for, but this event operates on a level of absolute completeness that defies our basic instincts. Once a single particle in some random corner of the universe successfully tunnels through the energy barrier, the boundary of reality is permanently broken. This tiny microscopic point of space collapses into the true vacuum, creating a microscopic seed of a completely new reality. This seed does not remain small, but instantly begins to expand outward, forming a perfect sphere of true vacuum that pushes against the surrounding space. This expanding sphere, often referred to by physicists as a bubble of true vacuum, is a wall of raw physical change. Driven by the massive release of latent energy from the decaying fields, the edge of this bubble accelerates almost instantly to the speed of light. We can visualize this like an incredibly thin, invisible soap bubble, expanding outward through a vast room, but instead of air, it is filled with a completely rewritten version of physics. Because the bubble travels at the absolute speed limit of the universe, it moves at the exact same speed as the light that would carry its warning. This means that there is absolutely no way to detect its approach before it actually arrives at your location. By the time the light from the collapsing universe could theoretically reach our telescopes, we would have only microseconds to register the event before we are swept inside. Imagine looking up at the night sky, watching the gentle silver glow of the moon hanging peacefully in the dark void of space. If the bubble of true vacuum were to approach our solar system from behind the moon, the lunar surface would not explode or crumble. Instead, in a fraction of a millisecond too fast for the human eye to perceive, the moon would simply cease to exist, its matter instantly dissolving as the new physics sweeps over it. A single second later, the edge of this silent, invisible wall would reach the atmosphere of our own planet. There would be no flash of fire, no violent shockwave, and no sound to warn the billions of people going about their daily lives on the surface below. At one moment, our cities are bustling with life, thoughts, and plans. In the next microsecond, every atom of our bodies is disassembled, our consciousness instantly extinguished without a single moment of pain. In their seminal research, physicists Sidney Coleman and Frank DeLucia described this terrifying event with a term that carries a hauntingly poetic weight. They called it the ultimate ecological catastrophe, a disaster so complete that it does not merely destroy environments, but the very possibility of environment itself. In this new, stable vacuum state, the fundamental forces of nature would be so deeply altered that they could no longer support the existence of complex structures. Chemistry, which relies on the precise sharing of electrons between atoms, would become completely impossible as atomic bonds dissolve. Without chemistry, biology cannot exist, and life in any form we can possibly conceive would be permanently erased from the cosmos. The universe would continue to exist, but it would do so as a cold, silent, and completely barren landscape, governed by rules that have absolutely no room for us. The true horror of a vacuum decay event lies not only in the complete annihilation of matter, but also in the subtle, devastating ways it could alter the individual fields of our universe. We often think of physical laws as rigid and unyielding, but they are actually held in a delicate, finely tuned balance that requires constant maintenance from the background fields. If the transition of vacuum decay were to occur with a slightly less aggressive shift, it could leave the universe intact, but subtly change the strength of its fundamental constants. Among these constants, gravity is perhaps the most familiar to us, acting as the invisible glue that holds our daily lives together. Even a tiny, almost imperceptible shift in the strength of gravity would have catastrophic consequences for the entire planet. Imagine a weakening of gravity by just 1%, a change so small that a human being would barely feel lighter as they walked down the street. Yet, this minor shift would immediately trigger a chain reaction of planetary scale, beginning with the very air we breathe. The invisible hand of gravity keeps our atmosphere tightly wrapped around the globe, maintaining the precise pressure that our lungs require to absorb oxygen. With gravity weakened by just a fraction, that atmosphere would instantly begin to expand outward into the cold vacuum of space, causing atmospheric pressure at sea level to drop rapidly. Every breath would become a struggle, resembling the thin, freezing air found at the peak of Mount Everest, even as you stood on a warm, sandy beach at sea level. As the pressure drops, the oceans would begin to boil at a much lower temperature, turning the life-giving water of our world into a choking fog of steam. The blue sky we love would slowly darken into a deep, bruised violet, and eventually into the absolute black of space as the protective shield of our atmosphere drifts away. We would watch our world become as dry and dead as Mars, all because of a tiny, invisible mathematical adjustment in the cosmic code. Larger, more significant changes to gravity would tear the planet apart from the inside out, disrupting the delicate equilibrium of Earth's deep interior. Our planet is a highly dynamic machine with a liquid outer core and massive tectonic plates that slide over a hot, semi-fluid mantle. These plates are held in place by the immense weight of the rock above them, balanced against the internal pressures of the planet. If gravity were to shift, this internal balance would be shattered, causing the tectonic plates to rupture violently and the continents to shift in a matter of days. Volcanoes would erupt simultaneously across the globe as the internal pressure of the mantle is released, filling the thinning atmosphere with choking ash and toxic sulfur. Far beyond the boundaries of our wounded planet, the consequences of weakened gravity would seal our doom in a slow, frozen twilight. Our sun is a massive, ongoing thermonuclear explosion, kept in a perfect state of balance by its own immense gravity. This gravity compresses the hydrogen in the stellar core tightly enough to trigger nuclear fusion, generating the light and warmth that sustains all life on Earth. If gravity were to weaken significantly, the star would no longer have the crushing force required to keep that nuclear furnace burning efficiently. Without the heavy pressure of its own mass, the sun would begin to expand and cool, its brilliant yellow light shifting slowly to a dim, ancient red. The nuclear fire at the core would begin to falter and fade, slowly freezing our entire planet under a thick sheet of ice, as our star dims and dies in the dark. While gravity holds the massive planets and stars in their orbits, there is a far more powerful force operating silently at the absolute smallest scales of existence. This is the strong nuclear force, the mighty cosmic glue that binds quarks together to form the protons and neutrons at the heart of every single atom. We rarely think about this force because its reach is incredibly short, confined entirely to the microscopic boundaries of the atomic nucleus. Yet, it is the strongest of all the fundamental forces, easily overcoming the powerful electromagnetic repulsion that tries to push positively charged protons apart. It is the silent, unsung hero of our physical reality, keeping the matter we see and touch from spontaneously flying apart. If a shift in our cosmic fields were to weaken this powerful force by just 1%, the consequences would be catastrophic and completely inescapable. Every stable element that makes up our world, from the iron in our blood to the silicon in our computers, would instantly become highly unstable. Atoms that have existed quietly for billions of years would suddenly transform into highly radioactive decaying isotopes. The delicate balance inside the atomic nucleus would be shattered, causing the tightly packed protons and neutrons to begin vibrating violently. These unstable nuclei would begin to break apart, shedding particles and releasing massive, lethal amounts of ionizing radiation into the environment. This would not be a localized nuclear disaster, but a silent global wave of decay emerging from within every physical object in existence. The air, the oceans, the soil, and our own bodies would suddenly begin to glow with a deadly, invisible heat as their atoms decay. The structural integrity of all solid matter would dissolve, causing steel beams to crumble into radioactive powder and solid rock to weaken into dust. If the strong force were to collapse entirely during a vacuum decay event, the very concept of matter would lose all meaning. Protons and neutrons would instantly disintegrate into their constituent parts, spilling their quarks back into the empty void. Imagine sitting in a quiet room, and suddenly, without a single sound or warning, the solid wooden table in front of you begins to lose its shape. The wood does not burn or rot, it simply dissolves from the inside out, turning into a formless, glowing mist of raw subatomic particles. Your clothes, the walls around you, and eventually your own hands would follow the same path, quietly unraveling like a knitted sweater when the thread is pulled. Without the strong force to hold the atomic nuclei together, no physical object could exist in its current form anywhere in the cosmos. The universe would be stripped of its chemistry, its structure, and its complexity, reduced to a hot, formless soup of lonely drifting quarks. This subatomic soup would be completely dark, as the photons of light would have no structures left to interact with. Every star in the night sky would instantly blink out of existence, not because they ran out of fuel, but because the very atoms that fueled them had dissolved. This is the ultimate form of physical unraveling, a quiet cosmic reset that leaves no witnesses behind to contemplate the empty space. Throughout our history, humanity has faced and imagined a wide variety of existential threats that could bring about the end of our civilization. We worry about the devastating consequences of a global nuclear war, the slow and painful collapse of our climate, or the sudden cataclysmic impact of a massive asteroid from deep space. These threats are undeniably terrifying, capable of causing unimaginable suffering and destroying the delicate systems that sustain human life on Earth. Yet, all of these disasters have one crucial thing in common. They occur entirely within the boundaries of our known physical laws. Because they operate within the rules of nature, we understand they are problems that we can theoretically analyze, prepare for, and solve. With unprecedented global cooperation, advanced science, and collective willpower, humanity could build bunkers, redirect asteroids, or heal a broken atmosphere. We possess a degree of agency in these scenarios, a small but significant hope that our intelligence and technology can find a path to survival. But a decaying vacuum belongs to a completely different class of threat, one that strips away every ounce of human agency and leaves us completely helpless. There is no scientific preparation we can make, no planetary defense system we can build, and absolutely no shield that can protect us from its approach. Unlike an incoming asteroid, which we can track with telescopes for decades, vacuum decay gives us no warning, traveling at the absolute speed of light. We cannot see it coming, and by the exact moment it arrives, the very concept of sight and observation is instantly erased. Imagine the most advanced human civilization imaginable, millions of years in the future, having conquered the stars and built structures of unimaginable power. These future humans might live in deep underground sanctuaries carved into solid planets, or within massive space stations shielded by powerful electromagnetic force fields. They might have unlocked the secrets of quantum energy and believe themselves to be the undisputed masters of their physical environment. Yet, when the expanding wall of the true vacuum reaches them, all of their incredible technology would fail in a fraction of a microsecond. This is because their advanced supercomputers, their heavy shielding, and the very atomic structures of their sanctuaries operate under the old physical laws. The moment those background laws are rewritten, the solid matter of their shields and the energy in their engines would simply cease to exist. You cannot use physics to protect yourself from a wave that is rewriting the very rules of physics itself. The advancing cosmic bubble does not care about our achievements, our history, our art, or our complex biological structures. It does not negotiate, it cannot be bargained with, and it does not slow down for any obstacle in its path, whether it is a grain of dust or a supermassive black hole. It is not an active enemy that harbors hatred or hostility toward us. It is a silent mathematical inevitability that simply overwrites reality as it passes. In its wake, there is no mourning, no ruin, and no memory of what once was, only a new, quiet canvas of space with a completely different set of rules. This absolute helplessness shatters our illusions of cosmic importance, revealing that in the grand design of the universe, our existence is a fragile privilege that can be withdrawn without a single word of warning. Human beings have evolved to experience time in a highly linear, orderly fashion, watching the seconds, hours, and days march forward in a predictable sequence. We use this linear flow of time to construct deep personal narratives, building stories that give meaning to our lives and help us navigate our daily existence. We wake up in the morning, consult our calendars, plan our careers, and save money for a distant retirement, completely convinced of the stability of tomorrow. Under this silent, powerful assumption, we write laws, draft constitutions, and build massive stone institutions designed to last for generations to come. We place our trust in the physical world around us, believing that the ground beneath our feet and the ceiling above our heads are permanent structures in a chaotic universe. But physics reveals that we are constantly mistaking repetitive, long-lasting patterns for true, absolute permanence. Just because the sun has risen in the east every morning for over 4 billion years does not mean that the laws of physics are locked into place forever. To a tiny creature whose life lasts only a fraction of a second, the heavy swing of a slow pendulum might seem like an unalterable, eternal law of nature. In the grand sweeping timescale of the cosmos, our entire 13-billion-year-old history is nothing more than a brief, flickering spark in a dark room. A cosmos that has existed for billions of years can still be fundamentally unstable at its deepest, most microscopic level, waiting for a transition that has simply not occurred yet. Throughout our history, we have learned to accept the harsh reality of change and decay on a macroscopic level. We understand that mighty human empires eventually crumble into dust, that grand cities are swallowed by the sea, and that even the most massive stars will eventually run out of fuel and die. We can find comfort in these deaths because they occur on a stage that remains intact. The actors may change, but the theater of the universe remains standing. Yet, the loss of the physical laws themselves is something that remains almost completely unimaginable to the human mind. We cannot truly conceive of a scenario where gravity itself stops working, where the very atoms of our bodies lose their structure, or where the stage of the theater is instantly folded up and erased. Our minds are built to process objects moving within space and time. And when we try to imagine the erasure of space and time itself, our thoughts simply falter and fail. The terrifying reality of false vacuum decay completely shatters our fragile sense of cosmic security, tearing away the comforting veil of permanence. It reveals that the universe we inhabit is not a solid, eternal fortress of stone, but rather a delicate, trembling glass sculpture that could shatter at any random microsecond. It reminds us that our entire existence, with all our grand plans, our deep loves, and our hard-won knowledge, is suspended over a quiet, subatomic precipice. This deep fragility does not mean that our lives are meaningless, but it forces us to confront the absolute limits of our control. We are travelers on a beautiful temporary island of stability, enjoying a quiet season of peace before the ocean of the true vacuum eventually reclaims the land. We are forced to realize that the stability we experience is not a guarantee of safety, but merely a slow, cosmic grace period. And in this grace period, we find ourselves holding on to a brief and precious moment of awareness, perched on the edge of the ultimate unknown. When confronted with the terrifying scales of modern physics and the potential for instant cosmic erasure, it is easy to fall into a state of deep, paralyzing dread. We find ourselves asking what the point of any human endeavor is if the entire canvas of our reality can be wiped clean in a fraction of a millisecond. This deep conflict between our desperate human search for meaning and the cold, silent silence of the cosmos is what the French philosopher Albert Camus
referred to as the absurd. In his classic philosophical writings, Camus described the human condition as a constant, heroic struggle to find order and purpose in a world that offers absolutely none in return. We look up at the vast night sky, yearning for a sign of recognition, for some divine confirmation that our suffering and our triumphs actually matter in the grand scheme of things. Yet, the universe does not answer. It simply continues its silent, cold expansion, completely indifferent to our tiny, flickering existence. The vacuum of space and the quantum fields that run through it are not actively hostile toward us, and they do not harbor any malice or desire to destroy our species. The cosmos is not a cruel enemy that we can fight with courage or trick with our clever technologies. Instead, it is something far more chilling. It is completely, perfectly indifferent to our existence, unaware of our thoughts, our pain, or our ultimate fate. The quantum fields would rewrite themselves just as easily if we had never existed, sweeping across our solar system with the same quiet mechanics that govern a falling leaf on Earth. This absolute lack of inherent purpose can feel like a heavy, suffocating weight, tempting us to slide into a state of quiet despair and total hopelessness. If everything we build is temporary and the ground beneath us is fundamentally unstable, we might ask ourselves why we should even bother to try. But Camus argued that this absolute indifference is not an invitation to surrender, but rather a profound call to ultimate freedom. If the universe does not provide us with a ready-made meaning, then we are completely free, and indeed obligated, to construct our own purpose every single day. Imagine sitting in a warm kitchen on a cold, quiet morning, watching the steam rise slowly from a fresh cup of coffee, feeling the simple warmth of the ceramic cup against your hands. You might share a quiet smile with a loved one, or take a moment to listen to the gentle rustle of leaves outside your window. These small, intimate moments of human connection and quiet appreciation do not need to last forever in order to be profoundly valuable. In fact, the absolute transience of our reality is precisely what makes each conscious moment infinitely more precious and beautiful to experience. Like a delicate wildflower that blooms for only a single afternoon on a high mountain slope, the brevity of our lives does not diminish our beauty. It defines it. We must carry our own light into the dark, finding meaning in our art, our kindness, our curiosity, and our love, precisely because the universe will not do it for us. This is our quiet, heroic defiance against the cold silence of the infinite void. We choose to love, to learn, and to create, knowing that our canvas is temporary, turning our brief existence into a work of art. By accepting the fragile nature of our existence, we can stop demanding eternity from a temporary world and instead find peace in the quiet wonder of the present moment. The cosmos we observe today is not a static, unchanging gallery, but the current chapter in a long and magnificent saga of transformation. Since the fiery dawn of the Big Bang nearly 14 billion years ago, the universe has rewritten its own appearance and structure countless times. It has transitioned from a hot plasma soup to a dark age of gas clouds, and eventually into a dazzling era of stellar nurseries, galaxies, and spinning planets. Our current era, filled with warm stars and stable chemical compounds, is just one temporary phase in an unimaginably long evolution. Modern physics has repeatedly forced us to accept a humbling and profound truth. Humanity does not occupy the center of this vast and silent theater. We live on a tiny, fragile speck of dust, drifting through the outer spiral arm of an ordinary galaxy.
which is itself just one of trillions of galaxies in the observable sky. Yet, despite our physical insignificance and our fragile position on a temporary ledge, something truly extraordinary has occurred on our small world. Over billions of years of quiet evolutionary work, cold, inanimate matter somehow organized itself into complex systems of chemistry and biology. The very same elements that were forged in the white-hot hearts of dying stars billions of years ago, the iron in our blood, the calcium in our bones, and the carbon in our DNAs, found a way to combine and breathe. Eventually, this complex biology blossomed into self-aware, conscious life, giving rise to creatures who can look back up at the very stars that created them. Imagine standing outside on a clear night, looking up at the pale band of the Milky Way stretching across the sky, feeling the cold air of the evening on your skin. In that quiet moment of wonder, you are not merely an observer looking at an external universe. You are a part of that universe looking back at itself. The eyes with which you see the stars are made of ancient star stuff, and the mind with which you contemplate the mystery of space is a product of cosmic evolution. We have learned to ask deep, difficult questions about our origins, our structure, and our ultimate fate, making our small species a remarkable and beautiful phenomenon. We are the sensory organs of the cosmos, the silent way in which the universe has managed to think, feel, write poetry, and seek to understand its own laws. Even if our time on this stable ledge is temporary, and even if a decaying vacuum will one day claim this entire corner of reality, our brief awakening remains a triumph. The fact that a universe made of cold, unthinking matter managed to wake up and know itself for a brief, glorious season is more than enough to make our existence profoundly meaningful. Our awareness is a rare, precious gift, a fleeting candle burning in a vast and silent room. We do not need eternity to justify the beauty of our song. It is enough that we sang, that we wondered, and that we looked into the dark with courage and curiosity. As we float together through the deep, unpredictable dark, let us hold on to this brief moment of light, finding peace in the knowledge that we have been, and always will be, a part of the grand awakening of the cosmos.